Hello, everybody. This is beautiful Monday morning, and it has given us an opportunity to meet and talk something technical related to very interesting subject that is convolution neural network. In short, we call it as a CNN. I will keep this whole lecture on YouTube in four parts, and you'll be able to refer it anytime. So we begin with our first part. Well, before we begin with this webinar, I would like to start this particular lecture with a very meaningful sloka of Kathopanishad, and this is very relevant to our this 1 hour of session. So let us begin our session with sloka of Kathopanishad. So here we go. Uh, I wish that we close our eyes for a minute and just chant along with Om Sana Vavatu Sanau Bhunaktu Saviryam Karvavahe Tejasvina Vaditamastu Ma Vidvishavahe Om Shanti Shanti Shanti. Thank you. And so, with the shloka of Kathopanishad, let us begin our session. First, I would like to tell you about our agenda for today. So, we will understand the concept of convolution neural network and understand how it works, how this special type of neural network work, and what are its areas. So we will also talk about research point of you as well. So what kind of task we can do with this and how we can implement this neural network with a real life example. So let us start this session. All right. Okay. Now, look at these beautiful birds. And when we see these beautiful birds and picture, our eyes act as a camera. It scans these images, it view them very fast and understand what these objects are. Eyes are our input, and like from input, we are gathering the signals, we are getting the pictures, objects, etc. And they do not process anything but simply capture that image and reflect on a screen behind the retina. And well, I am not going into a functionality of eyes and how it works, etc. It's none of our subject as such. But these images, which are reflected, captured by the neurons, and they understand their features. If you are looking at the birds first time, then it will capture these features and store in your memory with understanding that this is one bird. Look at these birds, how beautiful they are. They all are birds, but they have different characteristics. Some of them are having different colors and wings and different shape and color of beaks, different size, and all these are features of the birds that categorize them from each other. Okay, again, we have set of some wonderful animals here. So look at these very graceful animals, and the beauty is all of them are from same family, that is a cat family. But all of them have their own characteristics and features. So if you look at the cat, it's too cute, small, with different kind of nose and eyes. Look at that beautiful tiger. Okay, very elegant. The beautiful stripes and its nose and its eyes. And again, next one is the giant and graceful lion having hairs around. And again, very peculiar nose and eyes of the lion. Similarly, cheetah, black panther, jaguar, puma. All these beautiful animals are from same family but have different characteristics and features. And these features separate them from each other. And now it's a turn for human face. So many of these faces must be known to you, and those who are soccer fans must be remembering them very well. Here is one test for you. I give you half a minute and I want you to look at these all images and try to remember their associated names written below. Just look at them and remember their names. Okay, so like first from upper left is James. He is a famous soccer player from Colombia. Next is Albertino, and third is Ronaldo. Everybody knows him. In bottom line is very handsome Lionel, then followed by legend from Argentina, Diego Maradona, and a Brazilian soccer team T-shirt. Like we have very popular and legend Pele. Okay, so now identify them. Okay, in this particular image, who is who? Can you identify them all from upper left one? Okay, the first one is of course James. We can identify him easily because of his hairs. The feature hair definitely help us to distinguish him from other. And now the second image, any guess? Okay, who is he? Well, he is Sam James, but this time with different feature. Doesn't contain those long hairs, so our eyes couldn't recognize him at first glance. So now to identify him, what we check? Apart from hair, we look at the shape of nose, shape of lips, eyes, how eyes are apart from each other, color of skin, neck, etc. etc. Right? So, well, this is exactly what our CNN do. It build up the feature sets of images we pass from for the training purpose. It segregate the features and based on the features, it train itself. And once the model is trained, it identify them based on similarity of the feature sets. Our model identify objects, things, pictures, person, man, bird, X-ray images, MRI images, anything that contain features. So this is what our CNN do. We will learn in detail about this in actually coming slides, but let us justify these remaining pictures. The third person is a Lionel, but in this image with beer and of course race to Madonna and Pele, but this is their recent pictures compared to their younger age pictures that we saw in last slide. So let us continue and go to our main topic. Okay, I'm sure that majority of you are aware of the neural network and it resembles the formation of our brain. So the way our brain neurons are trained to classify objects, this particular neural network is also trained artificially to predict or classify. Here in an image we have shown in the first ever handwritten image of the neurons. It is an image drawn by scientist Roman Kegel and who draw the neuron system of a pigeon. Okay, so the neurons are consist of three main parts. Well, the first is the dendrites, which act as an input. It carries signal or data from terminal button or of other neuron and carry to nucleus, also called as a soma. Then the soma or the nucleus process this data and forward through the axons. And axons pass this data to the terminal button, which is also called synapse, and that forward to next thousands of neurons. And this is great arrangement by the master creator, the God. And we are trying to follow the same architecture and use this concept to build our artificial neural network. We follow the concept in similar way, and how we do it, let us see that. Okay, as we already discussed in previous slide, this is a handwritten first error image drawn by pigeon by the pigeon brain by the neuroscientist Ramon Kegel. Okay, and this is our replica of human neuron system. All right, this is our artificial neural network, giving you rough idea. The network consists of three layers. First is the input layer. All right, and the final one is the output layer, and between input and output layer we have hidden layers. The hidden layers are more than one in numbers. It depends on your requirement. All right, so we are not going to talk about neural network in details. We will just take a brief tour of it, and in case you are interested, all right, so I have already kept many lectures on artificial neural network on YouTube, so you can go through them and learn about the ANN in detail. But just for introduction, we understand that the neural network build based on three important concepts: forward propagation, backward propagation, and activation functions. All right. So this forward and backward propagation is iterative process. All right, that carried out from input to hidden to output layer and reverse from output to hidden layers. Strengthens the value of the weights by self-learning. Various activation functions are available, so we use them as per the requirement and they are linear or non-linear by nature. These activation functions are used to update the weights that make the neural network stronger and fit to predict more accurately. All right, then uh, we need to understand how it works. So we just take an example to understand this and then leave the topic and go ahead. All right. So here, suppose we wish to create a pink color. So we add two colors. All right. One is a red, another one is a white. So when we mix them at same quantity, we get pink containing red and white with the same weight, which we can predict as a pink equal to red plus white. All right, but assume suppose impurity also mix while we were mixing the color, then what will happen? We will have some different shade of the pink color. So this impurity we also call as a bias or the intercept. Moreover, if we add 60% of red and 40% of white, then our weight for the red will be 0.6 and white will be 0.4. So now our formula will be pink equal to intercept plus zero point 0.6 into red plus zero point 0.4 into white. Now we see that this pink is not as per our requirement. So what we will do? We will update the weights and the bias, and this is how we keep on creating the pink and then going back and upgrade the weights and bias and again produce the shade. This we do iteratively until we achieve our final best possible shade of pink color. That is our final outcome where our shades match with our requirements and there is no more scope to adjust weight and biases. Okay, so that was basic information about how forward and backward propagation works. To learn more about this, you can always go through my previous YouTube lectures that I have already uploaded regarding forward and backward propagation. It is beyond the scope for this particular current lecture. So like in next section, we go ahead with developing the CNN model. All right, so in second part, we will continue with this CNN part 2 and we will understand how we build a CNN model as well as we will also learn a real life problem and work on a coding, how to code it. All right, so very soon we will meet and see you soon with our second part of the lecture on CNN. I will upload it very soon. All right, so till then, have a wonderful day. Thank you very much. Have a great day.